Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate long division is a pretty lengthy process, right? It takes a lot of work. There's a faster way, and that's what I'd like to show you, and it's something called synthetic division. Now, this problem you see before you, we've actually already done using long division. Remember this? We did this whole bunch of work here, and we figured out this was the final form of the of the polynomial you see on the right. But not only could we use long division here, but we can actually do something a little bit faster. And it happens when you have a unique case where you know one of your factors. So again, on the right, you can see we have a factor. So we know one of the roots is going to be x plus 8 because the x-intercept is -8, okay? So what we're going to do this time, though, is instead of taking the root and doing long division, I'm going to show you how you do synthetic division. Synthetic division works really well here when you have a 1 as a coefficient on your x term. If you don't, then I recommend using long division. How do we set up synthetic division? The first thing you want to do is take your root and write it as your x-intercept. Next, you're going to take all the coefficients and write them up top. Do not write any of the variables. Now that our synthetic division is set up, here's the process. Take the first number, whatever it is, and just write it straight down. Now, we're going to take this number here, -8, whatever number's in that spot, we're going to multiply by this one. So -8 times 1 is -8. So take that answer and write it in the next column. Now add straight down. 12 minus 8 is +4. Repeat the process again, but except do it with the number we just got. So -8 times 4 is -32. Now add straight down. Repeat the process again, but now with the new number 9. -8 times 9 is -72. Add straight down. This last box will always be your remainder. When the remainder is 0, then we know it is a factor. So we know x plus 8 is a factor of this cubic because the remainder after dividing is 0. If the remainder is not 0, then whatever the root is that you're testing, whatever that linear quantity is, it can't be a root. It can't be a factor of your polynomial. So you have all this stuff. So what does this mean? Well, up top here, where did this come from? This came from the cubic, right? The numbers you get down here is 1 degree less from where it started. So if this started out as a cubic, then this turns into a quadratic. If this was the quadratic term, then this now becomes linear. If this was the linear term, it now becomes the constant. So this, whatever's left over here, turns into your new polynomial. And remember, what did we divide it by? The x plus 8. And if you remember from the last problem, when we did this with long division, see, that's the same answer right there. But remember, we figured out this piece was not factorable. So when you look, it's the same answer there. Much faster, much cleaner when compared to long division. But you have to know how to interpret what you get down here at the bottom.